A simple seaweed may hold the key to help cool our planet, at least in a small part. This is the story of how oceans-born seaweeds and grazing cows may have become unexpected allies to help our planet, the climate and the livestock. In the years to come, the fight against climate change will demand solutions both grand and subtle. Cows, sheep and goats burp climate-warming gas into our skies. Out of all the greenhouse gases released in the atmosphere, carbon dioxide, methane, nitrous oxide, etc., the methane produced directly by livestock digestion, especially from animals like cows, adds up to roughly 4 to 6% of global human-caused greenhouse gas emissions. So, just from the animals themselves digesting food, without counting what their feed required, land used or anything else, we're talking about nearly 1/20th or a bit higher of all emissions. But a tiny intervention may come to our rescue, a pinch of seaweed in animal feed that could reduce that methane by tens of %. In a recent study, researchers explored the potential of adding seaweed to ruminant diets as a feed additive to mitigate methane emissions. To understand how seaweed might quiet a cow's belch, we first must peer into the stomach of a cow, the rumen. Inside a cow's rumen, trillions of microbes break down tough plant fibers. Some of those microbes produce methane as a byproduct. It's part of their metabolic machinery. Certain red seaweeds contain compounds like bromoform, a molecule that, when ingested, interferes with the very biochemical machinery that produces methane. In experiments, inclusion of specific seaweed species in animal diets dramatically lowered methane emissions. Yet this comes at a cost. Bromoform is not benign. It may leave residues in meat or milk, or carry heavy metals like iodine or bromine. You may have heard of the gut microbiome, the community of trillions of microbes living inside the human digestive system. These tiny companions influence not just digestion, but mood, immune health, and even our social behavior. Studies show that people with close social relationships tend to share more similar gut microbiomes, both in composition and diversity. Is it diet, environment, or something else? Probably a mix, but the implication is that our microbiome influences our connections. And when that microbial balance is disturbed, what scientists call dysbiosis, the consequences can ripple into mental health. Anxiety, depression, impaired fear regulation, even altered cognitive flexibility. Thus, scientists walk a tightrope, reduce climate-forcing gas without poisoning food or harming animals. Moreover, widespread adoption raises supply questions. We cannot simply harvest wild seaweed at scale without ecological damage, and cultivating it in labs, farms, open seas brings its own barriers, cost, logistics, environmental trade-offs. What if, in our care to combat climate change, we inadvertently disrupt microbial ecologies, in animals, in soils, even in ourselves? Suppose seaweed-derived compounds accumulate in soil, water, or livestock systems, upsetting microbial communities we don't yet understand. Residues may linger in food, triggering hormonal or neurological effects. Seaweed farming may compete with marine habitats. We may rush technologies to market without full safety trials, only to discover damage later. Scientists warn precisely of this. The residue of iodine, bromine, or bromoform in meat or milk must be rigorously controlled. And scaling interventions always carries ecological ripple effects. Success is not uniform. Not all seaweeds are equal. What works in one region may fail in another. Local feed types, climates, microbial communities, even cow genetics, all can shift outcomes. What seems great in one trial may be ineffective elsewhere. Behind every feed additive is a network of farmers, regulators, ecosystems, markets, and ethics. Yet there is space for hope if we proceed wisely. If we pair seaweed additives with precision dosing, safety testing, traceability, and continuous monitoring, we can achieve better results. If we invest in seaweed aquaculture that enriches rather than degrades marine life, sequesters carbon, supports coastal communities, and fosters biodiversity, we may be able to embrace potential opportunities. We live in an era of urgency. Climate change demands bold action, yet boldness without caution risks unforeseen harm. The microbes in cows, in soil, in us, are co-creators of life's balance. Our responsibility is twofold: innovate with wisdom, test thoroughly, monitor continuously, involve communities, respect ecological limits, connect with the whole system, understand that humans, livestock, microbes, oceans and atmosphere form a deep web